Okay, so we've talked about end behavior and how to identify end behavior, but now we want to know more about what's happening in the middle part. Like we talked about, well, it goes, maybe we have a function that goes something like that, but we haven't really talked about what's going on here in the middle. So I'm going to draw like a little coordinate system here. And let's say our function looks like this. It goes up and down and then back up, something like that. Okay, and so we know, okay, it's got an odd degree and a positive leading coefficient. We can say that, but we want to talk a little bit more about the local behavior. One of the things we're going to talk about are the turning points. So the turning points are they're like the local, well, they aren't like, but they are the local, I'm going to erase the word like. They're the local mins and maxes. So we've already done that terminology. So like right here's a turning point and here's a turning point. So it's where it's changing from increasing to decreasing or from decreasing to increasing. So this function has two turning points. We can also talk about the Y-intercept. The Y-intercept would be right here. So the Y-intercept, that's when you're evaluating f of 0. That's when you're putting 0 in for the function. That's going to find you the Y-intercept. And then we can also talk about the X-intercepts. The X-intercepts are where it's crossing the X-axis. And so X-intercepts are when we, oops, I don't want an equation there. X-intercepts are when we set the function equal to 0. Okay, so let's see what we have here for an example. Given the polynomial function, and they give us a function there, written in factored form for your convenience. Now, it's kind of funny that they said that because we've been working with polynomials and we wanted them in general form, but this one, it's not in general form. They have factors for us, but that's helpful to us. It's for our convenience. And they want us to determine the Y and X intercepts. Okay, so let's do the Y-intercept first. So the Y-intercept says, let's find f of 0. So that's going to be 0 minus 2, 0 plus 1, 0 minus 4. So what's that? Negative 2 times 1 times negative 4, which is 8. Okay, so we know the Y-intercept is 8. So you could put it as an ordered pair. The Y-intercept is 0, 8. Okay, great. Now let's do the X-intercepts. So the X-intercepts, that's when we take the function and we set it equal to 0. Now's when it becomes convenient. So we have to know when each factor equals 0. So you can write them out as little equations, little linear equations, or you can just see that it's going to be 2, negative 1, and 4. So that we're going to have 3 X-intercepts. There's going to be one at 2, 0, one at negative 1, 0, and one at 4, 0. Those are going to be the X-intercepts. Now that's all this problem asked for. They asked us to find the Y and X-intercepts, so we did that. But I wanted to do a rough sketch for you so you could see how this all worked together. Now, what we're saying is up here at 8, 1, 2, 3, 4, 5, 6, 7, 8, that's going to be the Y-intercept right there. And then 2, 0, that's going to be an X-intercept, negative 1, 0, and then 3, 4. Okay, let me draw those in, 2, 0, negative 1, 0, and 4, 0. Problem is, we could draw a rough sketch if we knew the end behavior. But remember, they didn't give it to us in general form. Now you could multiply this out and take a little while to do that. Another way to do it though is the leading term is going to be x times x times x. That's what's going to happen there. And so you're going to get f of x equals x cubed plus blah, blah, blah. We don't really care so much about the blah, blah, blah. So we can get a sketch here because it's going to be coming up from the bottom. And then we don't really know how high up it comes, but then it's going to come down here. We don't really know how low it goes. And then it comes back up. This is a very rough sketch. We're not really graphing it, but we know the graph does something like that. Okay?